I'm going to run through some quick examples. I think that's probably the easiest way to pick this up. I'm going to cruise through pretty quickly, so there may be some points where you need to just pause the video and get caught up, or try it on your own ahead of time, or try the next one ahead on your own and just watch it and see if that was right. Before we can get started though, I need to give you just kind of a little formula we're going to be using for this particular section. If you are curious about this particular formula, feel free to read some of you, maybe you already have, but feel free to read ahead on some of the chapter and or the section and see if you can follow kind of why we're doing what we're doing. But for now, we're going to say u times v minus the integral of v du. And a couple different ways we can try to remember that. We've used u before, so I just kind of remember that it's going to be v, and then those aren't the same, so du, but you guys are all pretty bright. You'll figure out a way that you'll remember what's what. And so here's example 1. What we're going to do is we're going to identify what we're going to let be u. We'll take the derivative of it, and that'll give us du and dx, but we'll move the dx up to the right. We're also going to identify then what that means for v and dv, and that's going to be the case for every single one of these examples all the way down. Now I got a little trick for you to know what to look for, and then you'll see why we use this little trick. It's limit, logs, inverse trig functions, powers, exponent like e to the x or a to the x, and then just a regular trig function. And I'll kind of go back to that, but as we look, the first one on the list is what we want. If there's some logarithms in there, we're going to do that first. So I'm going to use the ln of x for my u. A little less thinking involved if you can remember that. And then we know what the derivative of ln of x is. That's 1 over x. And then this would be u dx, but we're going to multiply this up to the other side, and that's where our dx comes from. And so that's going to replace, kind of like with u substitution. So if you struggle with that, hopefully you've gotten better at that by now, that you're going to be able to replace this. But it should be easier because instead of trying to find where we're replacing this in the equation, I know there's our ln of x in the original integral. We're just going to end up rewriting this for our answer. Well, and then we'll do an integral because we'll still have one, but that's kind of where this is all leading to. So first things first, there's ln of x. We have 1 over x as our derivative. And so what we're going to do is we're actually going to let dv be whatever's left over. So instead of saying v is whatever's left over, I'm going to say if ln of x is the first part, I want to erase here, move my recording screen. We're actually going to let the leftover part, the x and the ln of, or the dx, be our dv. Really, you can make it simpler than that. One part of the function, whatever's first in that limit, is going to be your u, and whatever the other part of the function is, because it's a product, is going to be our x. So all year I've said, what's the product rule for antiderivative? And we said there is none. You have to use u substitution. Well, this would be as close to a product rule as we have. When you are doing the product rule, uv minus the integral of v du. U is ln of x, dv is x dx, and now we're doing the antiderivative, so we add a power and divide. That's our v then, and we're just going to rewrite this. U is ln of x times v, which I think I'm going to put in the front. So we have u and v being multiplied, minus the integral of v, because we've already taken the integral of it once, v, and then du, which is 1 over x dx. Now let me explain a little bit of why we do the limit. If you had a logarithm, I can't really combine an x and an ln of x, but the derivative of a logarithm doesn't have a logarithm, so if you had a power with that, you're going to be able to combine it like we have here. It's going to work out real slick. And a power would get a more simple power, and there's reasons for each one being in the order it is, and I'll get to explain that as we do some others, but that's kind of where we're going. So we use the logarithm. In my new integral, there's no logarithm, so I'm going to rewrite this one last time. This whole thing, I'm going to rewrite The first part's just going to be the same, and I'm sure there's some simplifying we could do, but we'll just get it done and we'll leave it as is. And then this can be simplified before integrating, so instead of x squared over x, we'll just do x. Maybe even take out that 1/2 if it's easier to do the integral. So really what we have is 1/2 minus 1/2 the integral of x. Antiderivative, that would be x squared over 2. Don't forget your plus c because I don't have bounds. And you can see I could probably simplify that. You know, maybe the best thing to do here would just be to take the 1/2 and say, okay, 1/2 times 1/2 is 1/4. But we could easily get a common denominator or factor out an x squared and do some things. But right now we're just trying to get the basic down of what we're doing, so maybe I'll just leave it as that. If you want to see that one more time, it's a pretty straightforward example. Feel free to pause it and go back and watch. And the others will go quicker now that we've, you know, kind of gotten through kind of the logistics of how some of that work. Let's do another one. What are we going to let be u, and what's going to be dv? So we're going to have a u, a du, a v, a dv. No logarithms, that's the L, and I'll write that L-I-P-E-T, that acronym out again. There's no inverse trig functions. I mean, if we do a sine and we do the derivative of sine, the reason trig is last because you get cosine, just goes back and forth and we don't get anywhere. We keep getting the same thing. The third one is a p, that's a power. Well, x to the first power be considered a power. That's what we're going to let be u. Du then is just derivative of x is a 1. You don't even have to write that if you don't want to. And then dx. And then whatever's left is going to be the dv. So the sine of x dx is our dv. Antiderivative of that would be a negative cosine of x. And we're going to rewrite it. I have u times v, so times the negative cosine of x, minus the integral of v, which is also a negative cosine of x. You could factor out the negative and end up with 2 positives there. I'll do that right now. And then du, which is just a 1 dx. The reason powers is so soon on the list in our lipit is because when you take a power, we have one less power, and it's going to simplify what we had there, especially if it's to the first power. It's just a constant. It's kind of like it's not even there, though, and I can definitely take the integral of that. So this whole thing is going to get rewritten. Man, this is going quick now that we've kind of walked through how it works. So if you need to pause and go back and look at it again, feel free. But there's the u and the v, and here's what I get when I take the integral of the v du. It would just be the antiderivative of cosine, which is sine. Don't forget your plus c. Not too bad. You want to maybe pause and try the next one? Oh, you know what? Look at that. We're just doing ln of x, which maybe some of you already know is x ln of x minus x. Remember the all new u? U ln of u minus u. Just had a cheesy way to remember it. But what we're going to do is we're going to do this using integration by parts here. So like the other ones, you can always start here. You're going to have a u and a du, a v and a dv. Flip it. The L is log, so if we have a log, we're going to let that be our u, our derivative of that would be 1 over x ln of x. What does that leave for v then? Or not for v, dv. That's important. We're letting part of this function be u and the other part be dv. It's just a 1 or just a dx. Either way you look at it, just dx there. The antiderivative, that would be 1 power higher, so x to the first over 1, which is just bx. And then we'll rewrite it. We'd end up with u and v, so x ln of x, that's u times v, minus the integral of, well, v, which is x, and du, which is, remember, that's just what we're memorizing. uv minus the integral of v du. So I'm not just like, I'm not choosing those for different reasons. That's what we're going to do every single time. I've got u and v being multiplied there in a different order just because of what they were, but still, that's u times v, and I've got the integral of v, which is x, and now du, which is 1 over x dx, which that just kind of cancels to 1. Antiderivative of that is just an x. We get x ln of x minus x. Don't forget your plus c. Cool. There it is. U ln of u minus u. That's what we had memorized for ln of x. Just see how it works. Pretty cool. Actually, we had done that another way. We had taken the derivative of that and verified that that would work. But that's number 3. We're going to do at least a couple more here. Again, if you want to pause and try one on your own, feel free. This is the tangent inverse. And we're not doing too much for this one because we might have memorized this, but even if you didn't memorize this, so if you already know it's 1 over 1 plus x squared, that's great. We should get that same thing. Then let's kind of see what happens. We would let that inverse, well, that's what we memorized for a derivative. We didn't memorize the antiderivatives, so I guess we wouldn't even be able to do that. So u du v dv. Okay, let's do tangent inverse of x. That's from Lipit, that's the I. That's an inverse trig function. That way you can do the integrals with the same kind of thing without having to memorize the antiderivative. So the derivative of that we know is 1 over 1 plus x squared, or maybe you'd forgotten that by now, but that's the derivative of tangent inverse of x. And then if we use that tangent inverse of x for u, then the only thing left for a dv is 1 dx, or just dx. Antiderivative of that would just be x. Again, you're picking u, you're picking dv, whatever's left for dv. A lot of students sometimes will forget and they'll do u and then v, but it's got to be the u and the dv that get written down, and then the v and the du we get by either doing the derivative of u or doing the antiderivative of v. But at this point we just have memorized, and we're going to write down u and v together. Can look like a mess, doesn't matter, it's just going to be what our antiderivative is, so that's a mess. U times v minus the integral of v du. Well, that's v, and du is 1 over 1 plus x squared dx. Well, okay, that looks not quite as bad because you don't have the tangent inverse. So then what would we do? Can you simplify that? You're going to love this. What's the quotient rule for antiderivatives? You're right, there is no quotient rule, so what do? You try u substitution. So forget about the u and the v that we did the first time. We've already used that, done deal. We've got a new integral set up. We're going to do the second part of this answer by doing u substitution. We're going to let u equal 1 plus x squared. Kind of fun. Some of you guys might be sighing, but this is kind of cool to just see it all come together. And just wait till the last one. Maybe have a whole board worth of stuff if we were doing this on the chalkboard. But not your typical one, but still kind of fun to try to figure out. Derivative of that would be a 2x dx. And so we're going to replace what we have in the integral here with, let's see, the bottom's going to be u. And that, well, that's not exactly, we need to divide both sides by 2. So the x dx is going to replace with 1/2 du. So the x and the dx is getting replaced with 1/2 du. Antiderivative of du would equal, so we'd have 1/2 natural log of absolute value of u plus c. And we're going to write all this stuff down. So don't forget, we have all that first part. I have x tangent inverse of x minus whatever I get for the integral, which is 1/2 natural log of the absolute value of u, which actually, because because u is 1 plus x squared, we don't need absolute value. Something squared is always going to be positive, so you don't need the absolute value there. We could just have just a regular parenthesis and then our plus c. There's my yay bubble, all done. So not too bad. If you can do u substitution, it might just be, doing the integration by parts and then doing one after that. And this last one that we're going to do, before we get to a fun one, actually, I know I said the reason we're doing this, even though it wasn't on a calc exam, is because if you're going to go on to Calc 2 next year, they're going to think that you've done this already in Calc 1. It's from Chapter 6. It's a Calc 1 topic. if you guys are going to retake Calc 1 in college, there's a good chance you're probably going to do this next year, so it'd be nice to have seen it. But my Calc 2 student, well, not my Calc 2 student, but one of the Calc 2 students that were working towards taking the exam this year was doing one like number 6, knowing that something like that's going to be on the AP exam. So number 6 will be a little crazy, but it's kind of where we're going. Some of the math is getting pretty complex, and there's a lot involved, and we're trying to do the best we can with it. So we'll see how you do. Maybe you want to try some of the easier ones on the homework before jumping right to try number 6 if you think so, but I think it's always fun to try. Okay, number 5. U du v dv. This is kind of an easy one to know what to start with, because lipit L, that's log, that's first thing, and it's there, so we're going to use that for u. Derivative of log is 1 over x dx. And let's see, v, well, that's actually, think of that as an x to the negative second there. So our dv, remember it's dv that we're going to do, is actually x to the negative second dx, which makes v, if you add a power, you get x to the negative 1, divide by negative 1, you're just going to get a negative. And now we're just going to rewrite our answer. We're going to say u and x, or u and v, multiply them together. Doesn't matter what we do. So the ln of x, we've got a negative sign in there. X to the negative first is x on the bottom. So I'll just put that on the bottom. Minus, remember we're just memorizing this. U, v, minus v, du. That's what your answer is going to be. I'm just rewriting that same thing, plugging in, just erasing and replacing u and v and du. Okay, so v again is a negative x to the negative first, which those two negatives will cancel out. That's kind of nice. And then du is also 1 over x, which is the same. I'll put over 1 over x dx, which is the same as x to the negative 1. So what's 1 over x times 1 over x? It'd be 1 over x squared, or x to the negative second. Or you could think of it x to the negative first times x to the negative first. So I'm going to scribble out this guy and just say we have x to the negative second. If I'm going too fast, pause and back up a little bit. You know, catch up in your writing and go back and watch up to where we are at. What's the antiderivative of x to the negative second? You'd add a power, which would be to the negative 1, and divide. That's kind of what we did before. And then we have this negative ln of x over x as well. Plus c, I can't resist. It's too close. This is the same as 1 over x. See how they have a common denominator? Let's just put it together. We've got a negative 1 and a negative x. You could even factor out the negative. Put the 1 first. Maybe I will. Negative 1 times 1 plus. You don't have to rewrite it. Sometimes when it's going to clean up so nicely, I can't hardly resist. So pretty. Okay, there we go. That's our example 5. I'm going to do one more that's going to have to kind of be done a couple times. So if you're not up for that yet, maybe pause it and go back and watch the video for the homework one through the first few at least, because I'm sure you won't get one of these like the first problem. Otherwise, do one more. And if you want to try to do it the first time and at least get it set up, that's fine. You won't be able to just go through and be done with it, but still, you'll be able to, I think, get through part of it. I'm going to keep going here, though. Start off to the side, so I got a lot more room. U and du, and v and dv. Let's see. Lipet. Trig is always last. Don't even think about using the cosine of x for u. That's the t. It's not gonna simplify things. But by using the u, that means our du is gonna be simplified because that gets put in our integral. It's just gonna be a 2x dx. Antiderivative of cosine of x is sine of x, and we'll rewrite it. I'm gonna start all the way over here on this side. Here we have. I'm gonna say this is. You'll see kind of why. So this is what we're doing. We're going to say that this integral that we're looking for to find equals, remember, uv minus all that. Okay, so u v minus the integral of v du, which is still a 2x dx. So we still have a product there. And I still can't do u substitution with that. so it didn't work. At least doing it that first time. So that's what we get. Those are equivalent statements, though. I do know that those two things are the same. What we started with does equal that. But I'm going to do this again. I'm going to take this integral out, and I'm going to replace it with something else now. I'll do my, so forget about those earlier u's and du's and stuff. We've been there, done that. I'm going to do it again and have a new u, new du, v, and dv. This time with what I have there, again, the trig, don't use the trig for u, so I've got a sine of x and a 2 of x in the one that we're going to replace still. I'm going to use the 2x, and each time you do this, now we're just doing x squared. If you had x to the 4th, you'd have to do this like 4 times. With x squared, the first time we did it, well, we got it down to a 2x. The next time we're doing it, now we're down to a 2, which won't affect our integral when we plug that in. We'll just have a trig function. You'll see in just a moment. And that leaves our trig function again to be dv. Do the antiderivative of that, you get negative cosine. And we're just going to rewrite this. So instead of that integral, now careful, it's minus the whole thing. So it's minus that integral. So when we go to rewrite this, make sure everything is in there. That's really tricky. A lot of kids forget that. We've got u and times v, so that's going to have a negative then cosine of x, minus the integral of v, which is also a negative cosine of x, du, which is 2x, or 2dx. I'm gonna put the 2 out here. Also, if you notice, I have 2 negative signs there that are going to change to positive. I have that whole thing negatives. Now, the negative here is going to change. If you want to do this now, we could change those to positive, but that's going to change back to negative. Some point, you got to take care of that. I'm going to do it right now while I'm thinking of it. Remember, that's all because of that whole integral that we're starting with is being subtracted. And actually, if I do that, I can get rid of my parentheses now. That's all good. The signs are good with what they need to be. I've changed them. So that's what we have after doing all that. Again, if you didn't follow that, maybe go back and watch it one more time. Just make sure that negative sign gets distributed. I can do the negative cosine of x now. The negative 2 integral of cosine of x. What does that equal? Antiderivative would be, let's see, we just end up with, antiderivative would be sine of x with the 2. That'd be minus plus c. And I've got that term, all 3 of those terms there. And that really was not as bad as I even remember it being. Man, I remember having to go back, and maybe I did it a different way last time. But it looks like I was able to just pull that off. If you ever get one that can't simplify all the way down with that power, you actually end up having to do like a repeat with it. And I thought that was going to be this one, but maybe not. I'm pretty sure that's where we end up. So that's it, 23 minutes. But something brand new, and feel free to go back and watch it again or read through the book and see if they do something a little different. And we'll try, typically this would be the notes, and then you'd have about the same for practice. And I'll make a video so you can check the practice rather than just your answers for that too. I'll call this video integration by parts, and the next one the practice.